Now today in class 11th, I will tell you the tension in the string and velocity of the particle when moving in a vertical plane. So before this I have told you about the circular motion in the vertical plane. There I told you that how to find the velocity and the energy of the particle at the standard points. At the lowest point, highest point, the points which are at the horizontal position. And today I will tell you that how to find the tension and the velocity when the particle is at any angle with the vertical direction. So let's this is a center point. These are the points the particle is moving like this. This is the motion of the particle. And this is the radius. It is the radius. This is the string. This is the string. And this is now point P. This is point Q. This is now R. This is now S. When the particle moves in the vertical plane, its velocity is no more constant. So this is the non-uniform circular motion. The motion in vertical plane is non-uniform circular motion. Let T equal to tension in string at point A and V equal to velocity of particle at point A. So this is the point A. This particle is tied at one end of the string and the other end is kept in the end, and then this is rotated in the vertical plane. Let this makes an angle theta from the vertical, and the tension in the string is T. Here the weight of the particle will act vertically downward. If we increase this line in this way, then this angle is also equal to theta as the angle are corresponding. So we can have the components mg cos theta and one component along this one, that is your mg sin theta. and descended. So now let's the forces acting on the particle. Number one, the tension T in a string, and number two, weight mg of particle, and three, the centripetal force. This is equal to mv square upon r. So now these are the two forces which are opposite to each other. The resultant of this T and this mg's cos theta will give you the centripetal force. The resultant of T and mg cos theta provides centripetal force. I have told you earlier that centripetal force is provided by some force. Either this may be the tension in the string, it may be the gravitational force, it may be the Lorentz force, it may be the magnetic force. So whatever we are having the force that provides the centripetal force, only then the particle moves in the circular path. So this T minus mg cos theta equal to mv square upon. This is what the resultant of these two is providing the centripetal force mv square upon r. Or we have T equal to mv square upon r plus mg cos theta. Let this is equation number 1. Then we suppose let Vp equal to velocity of particle at lowest point P. So this is now lowest point. Here we are having the velocity like this. This is in this direction. Here the velocity is in this direction. This is the velocity in the direction of the tangent. This is the velocity. So we are having different velocities in the different points. So now we can find this velocity V, the velocity. V equal to square root of Vp square minus 2g, and then let this is now height, suppose h. This is the height h from here. This is now height h. So this remaining will be r minus h. This is now r minus h. This so much is r minus h. This is now suppose this point B. Then this BP. This is equal to r minus h. So now height is how much? R minus h. So we are using the equation b square equal to u square plus 2gh. In place of u, we are having this bp, the velocity at this point p, and this the vertical height, that is now r minus h. Now from triangle, this v equal to square root of, we know that the velocity at the lowest point, this is equal to square root of 5r. Square root of 5r, this is now whole square, minus 2g, and this is now your r, this is now minus r cos theta. Now from this triangle OBP, h equal to r cos theta. So now what we have? This is equal to, if you just simplify, then this will come out to be your 3rg plus 2rg cos theta. This is equal to what? The velocity. This is velocity at point A. This is now point A. At point A. So this is now number 2. Then what we have? We will put the value of B here from this one. So we will get another expression in this one. Putting value of B in equation 1. What we get? This T equal to m upon r. Now v square, so this will cancel. This is equal to 3rg plus 2rg cos theta plus, no, this is minus minus, this is not plus, plus this mg cos theta. So what we are having? If we multiply to this, then r will cancel from all these. So this will be our 3mg. T equal to 3mg. This will be now 2mg cos theta, and this is now mg cos theta. So this is now 3mg cos theta plus 3mg cos theta. Now you take common 3mg. So now T is equal to, this is now your 3, and you take common, this is now 1 plus cos theta. So this is the tension that will give you at any angle theta. This is now equation number 3, and this equation number 2 will give you the velocity of the particle at any point. The equation. So now you can have that we have taken the point P, Q, R, S. So at point Q, what we have? Theta equal to pi by 2 or 90 degree. So these are the horizontal points. So now we are having this V equal to, now from here you can find this cos theta is square root of 3rg plus 2rg cos pi by 2. This is now in 0. So this is now square root of 3r. This is now equal to b. This is now b. Now tension is what? Tension equal to, this is your 3 mg into 1 plus cos pi by 2. So this is now your 0. So this is now your 3 mg. So tension at this point Q is so much, velocity is so much. And now at point R, at highest point R, theta is equal to pi radian. So now what we have? This velocity will be how much? Now velocity is V. V equal to square root of 3 Rg plus 2 Rg cos pi, and cos pi is equal to minus 1. So this will be minus 2 Rg. So this will come out to be V equal to square root of Rg. This is now critical velocity, and the tension T equal to, now from here T equal to 3 mg into 1 minus 1 plus cos pi, and cos pi is equal to minus 1. So minus 1 plus 1, this will be equal to 0. So this tension T is equal to 0. So what we have? That the highest point the tension is 0 and velocity is equal to square root of Rg. Now at point S, now this theta is equal to 3 pi by 2 radian. So what will we have? The velocity V equal to, the velocity is equal to your square root of 3 Rg plus 2 Rg cos 3 pi by 2, and cos 3 pi by 2 is equal to 0. So V equal to square root of 3 Rg. Now tension, this T is equal to 3 mg into 1 plus cos 3 pi by 2. So this is now again equal to 0. So you are having T equal to 3 mg. So, and again at the lowest point, at lowest point P, theta is equal to 2 pi. So when theta is equal to 2 pi, then what will be the tension in the velocity? Velocity V equal to square root of 3 Rg plus 2 Rg cos 2 pi, and cos 2 pi is equal to 1. So this V equal to square root of 5 Rg, and the tension this T is equal to 3 mg into 1 plus cos 2 pi. Cos 2 pi equal to plus 1. So this will be equal to 6 mg. 6 mg. This is equal to T. So now you can get the conclusion from this, that what will be the tension and the velocity at the different points. So at lowest point This I have told you the velocity and this tension, and at the highest point, the point R, this is equal to so much. So difference in number one, difference in tension at lowest and highest points. Now this will be how much? This is equal to 6 mg minus 0. So this is the T, or we can have this T P minus T R. This is equal to 6 mg. Now difference in velocity. At lowest and highest points, what we have? This means that at lowest point, this is now your Vp minus Vq, QR, this is now R. So this is at the lowest point, I have told you this is equal to square root of 5Rg. And this is square root of Rg. So this is equal to square root of Rg into square root of 5 minus 1. This is equal to so much. If you put the value of square root of 5, then this comes out to be 2.236. Square root of Rg into 2.236 minus 1, so much. So this is 1.236 into square root of Rg. This is what the difference in velocities. This is now Vp minus Vr. This is at lowest point, this is at highest point. This is so much. And now then, number 3. Difference in tension at horizontal points Q and S. What we have? This delta T. This is now your T Q minus T S. This is equal to your 3 mg minus 3 mg. So this is equal to how much? 0. T Q minus T S. Similarly, difference in velocities. Now number 4. Difference in velocities at horizontal points Q and S. What we have? This VQ minus VS, this is equal to square root of 3RG minus square root of 3RG. So this is equal to 0. This is equal to VQ minus VS. This is so much. So what you find? That the difference in tension at the lowest and highest point is equal to 6 N, the 6 times the weight of the body. And the difference in velocities, this is equal to 1.236 into square root of RG. And that if you find the tension at the original points, the difference in tension at the original points, this is equal to 0. Now you can find the difference of the tension and the velocity at the horizontal points and lowest point. Now number 5. Difference in tension at lowest point P and horizontal point. Points this Q or S. What we have? This is now your TP minus TQ. TP is equal to how much? This is now your 6 cm. This is now your 3 cm. So this will come out to be TP minus TQ is equal to 3 mg. This is so much. Similarly, now we take the 6 points, the difference in velocities at lowest point P and horizontal points Q or S. What will do? This is now your VP minus VQ. This is equal to square root of 5RG minus square root of 3RG. Now you can find from here that this VP minus VQ, this is equal to, you take common square root of RG, then this is square root of 5 minus square root of 3. So this is equal to square root of RG. This is now your 2.236 minus 1.732. So this is to be how much? 6, and this is now your 4, and this is now 3 and 3 0. This is now 2, so this is now 12, then this is now 5 minus point, then 2 minus 1, 2 this is now 0, this is not so much. If you subtract to this, then this will come out to be so much square root of RG. This is now difference in velocities, VP minus VQ. If you take the difference in tension and the velocity at the horizontal points and at the highest point, difference in tension at horizontal points are this Q or S, and highest points R. This will be how much? This means that you are getting this your T Q minus T R. So T Q is equal to square root of 3 mg, and tension is there 0. So this T Q minus T R is equal to 3 mg. This is so much. If you find the difference in velocities, at horizontal points Q or S and highest point R, then you will get it then this will be your difference in velocities. So this is now your VQ minus VR. VQ equal to square root of 3RG. This is known as square root of RG. So this is square root of RG, and this is square root of 3 minus 1. So you will find that square root of Rg into 1.732 minus 1. So this is 0.732 into square root of Rg. This is now your VQ minus VR. This is so much. So what you see, that difference in velocities at the lowest point and the horizontal point, at the lowest point and at the horizontal point is less than the difference in velocities at horizontal point and the highest point. This is now 0.732, this is now 0.504. So this velocity is less than this one. Similarly, if you find the tension, difference in tension at the lowest point and the horizontal point, then this will be less in comparison to the difference in tension at this lowest point and the highest point. So at lowest and highest point, the difference in tension is equal to 6 mg. There the difference in tension is equal to 3 mg. So this is what we have a comparative study of the difference of the velocity and the tension, and with the help of the equation 2 and 3, you can calculate the velocity and the tension at any point, at any angle which is taken from the vertically downward position to any other position when the particle is rotated in the vertical plane. So this is what the tension and the velocity of the particle in the vertical circular motion. So this is the case when the velocity of the particle is no more constant. So this is a non-uniform circular motion. Thank you very much.